How to estimate nitrogen loss in these saturated fields. The basic thing we're trying to do is figure out how long until the nitrogen application you've made converts to nitrate, which is NO3. And the three ways that can happen is volatilization, and that would be more urea-based products. And if you got a half-inch of rain or was incorporated, you really don't have to worry about that. Then leaching is the movement through the soil, and again, when it converts to nitrate with the negative charge and moves through the soil with a negative charge, it will not attach to the soil, so it'll move on through. And then the third process, which is the main one we want to talk about, denitrification. It happens when the soil is saturated, nitrogen's all moved out, anaerobic conditions. The microbes switch from feeding off of the O2 to feed off of the nitrate, and then as that happens, the nitrogen is released to the atmosphere. As you look at this chart and select the fertilizer sources that you may be using, and note how long it does take them to convert to nitrate in a saturated soil condition. Especially note then UAN. Really, there's three products there that make that up. 50% of it is urea. 25% is ammonia, and then the other 25% is nitric acid, which is already in the nitrate form, and that's how those convert. Denitrification is a biological process, and so the warmer it is, the faster it'll happen. And temperatures from 55 to 65 degrees in saturated soils, it'll take it 2 to 3% a day. And if it's over 65 degrees Fahrenheit, it could lose 4 to 5% in a day in saturated soil conditions. As you try to make up for the lost N, side dressing is going to become probably the best option. I just put together here an example saying that 160 units of UAN was applied pre-plant before May 1st, and then remember UNA is really made up of the three forms of nitrogen source. One is the nitrate form, 25% of it's already in that form, and then 80 units would be in urea. And in this example, we're saying 50% of that is left and hasn't transferred to nitrates to give us 40 units there. And then finally, 25% of that 160 comes from ammonia and has converted to nitrates. So we got 120 units to work with. And if you go back to that chart here earlier in the video, we show about 4% loss per day. We're going to use 5 days figuring, although this was underwater for 7 days, but it takes 2 days for the conversion to happen to nitrate. So, and again, remember, there's a great amount of variation across all fields. Ponding is localized, and those loss, and these figures are obviously theoretical. But again, options, and it gives you kind of a ballpark figure, that 24 units of N lost to work with and what you might have to make up.